Hello, welcome back to another video lecture on basic algebra. Today we're going to be talking about negative exponents. So first let's kind of refresh a little bit about exponents. A to the n is a times a repeatedly multiplying by itself, and we multiply this n times. So we're not going to really specifically go over proving these rules, but we're going to go ahead and look at these rules real quick. So some of the rules that we have for exponents, we have that a to the n times a to the m is equal to a to the n plus m. Then we have a times b, all of that to the power of n, equals a to the n times b to the n. We also have a to the n times, brought to the power of m, equals a to the nm. A over b to the power of n is a to the n over b to the n. We have a to the m divided by a to the n equals a to the m minus n, and a to the 0 equals 1. So our negative exponents rules that we're going to be introducing are these two. So a to the negative n equals 1 over a to the n, and 1 over a to the negative n equals a to the n. So let's kind of show a little bit of the informal proofs of those two negative exponent rules. So if we use Rule 5 says that a to the m divided by a to the n is equal to m minus n. So if m is 0, then we get a to the 0 over a to the n equals a to the 0 minus n. And 0 minus n is just simply negative n. Using Rule 6, a to the 0 equals 1, so a to the 0 over a to the n is just 1 over a to the n, which equals a to the negative n. Then, using Rule 7, which we just showed, since a to the negative n is 1 over a to the n, we can say that 1 over a to the negative n is the same thing as 1 divided by 1 over a to the positive n. This equals 1 over 1 times the reciprocal of this, which is a to the n over 1, which equals a to the n. So let's look at a quick few examples on how to use this. So we're going to use x squared over x to the fourth to show that x to the negative 2 equals 1 over x squared. So we can go ahead and say, well, x times x, this is x squared, x times x times x times x, using our definition. This simply equals, when we cancel out these 1s, or these x's up here, we end up with 1 over x squared. And we could say that x squared over x to the fourth, this is x to the 2 minus 4, which equals x to the negative 2. This and this are the same, which means that 1 over x squared is the same as x to the negative 2. So we're going to go ahead and rewrite these so that we have positive exponents only on this example. So 2 to the negative 4, when we rewrite this to have positive exponents, it's 1 over 2 to the fourth. Here we have negative 2 to the negative 4. This is negative 1 over 2 to the fourth. Now this one is going to be 1 over negative 2 to the fourth. So here, the negative stays within this parentheses because it's within the parentheses here. Whereas with this one, the negative stays outside of this fraction because it's outside and the exponent does not affect the negative. So we're going to look at one more example. It's going to be a little bit more complicated. And all we're going to do is we're going to simplify this using multiple rules. So if we look at this, we're going to start with this negative exponent out here, and we also have a positive exponent here, but we're going to focus with this top side first. So we're going to actually be using rule 2 for this, where this is a negative exponent here. And we're going to bring that into the terms inside and combine it with this one at the same time. So using rules 2 and 3, on our top here, we get x and then squared times that negative 4 times y to the negative 2 times that negative 4. So these each go to each one of these values using combinations of rules 2 and 3. We can do the same thing at the bottom. We're going to bring this 2 and distribute it to both exponents. So this is x to negative 1 times 2 times y to the 2. So let's go ahead and simplify these exponents. We get x to the negative 8 times y to the positive 8 over, here we've got x to the negative 1 times 2, so this is x to the negative 2, and y is squared. So we're going to go ahead and separate these as two separate fractions temporarily so that we can keep just the certain variables with their exponents separated. So we're going to say x to the negative 8 over x to the negative 2 times y to the 8 over y to the power of 2. So we're going to go ahead and simplify this one first, because this is the easiest one to do. And since we have this one minus, or since these are dividing out, we say this minus this, the 8 minus the 2. So for our y's, we end up with a y to the 8 minus 2. And for our x's, we get x to the negative 8 minus negative 2. That's by rule 5. So we're going to go ahead and simplify all of this. This is x to the power of negative 6 times y to the power of positive 6. Oops. And this equals y to the 6th over x to the 6th. And that's our simplification. You could take it an extra step and just say this is the same thing as y over x to the power of 6. But that's usually a pretty acceptable form to leave it in. So that's going to be it for this video. I hope you learned something about negative exponents and how to work with them, as well as how to combine them with other rules. Hope you enjoyed the video, and I'll see you in the next. Goodbye.